Diaphragm-type deluge alarm valve. The diaphragm-type deluge alarm valve produced by our company is designed, manufactured, and accepted in accordance with the standards of GB 5135.5-2018, Part 5, Deluge Alarm Valve. The connection methods are flange connection and groove connection. The sizes of the flange connection include DN50 to DN350, and the valve group materials include ductile, cast iron, and stainless steel. The sizes of the groove type are DN100, DN150, and DN200. The installation method can be divided into vertical installation and horizontal installation. Product description. The diaphragm-type deluge alarm valve is composed of valve group, deluge valve opening pipeline, solenoid valve, anti-reset device, control chamber water supply pipeline, alarm pipeline, pressure switch, hydraulic bell, drainage pipeline, and pressure gauge, etc. It forms an open fire extinguishing system with water supply equipment, pipeline systems, control valves, such as inlet and outlet signal butterfly valve, opening nozzle, fire detection device, etc. Working principle. When a fire occurs, the fire detector acts and reports to the fire alarm controller, links the solenoid valve, the diaphragm chamber depresses, the deluge valve opens, the pressure water flows into the pipe network. The system is converted to a wet system. At the same time, the hydraulic alarm bell and pressure switch act. The linkage starts the fire pump to supply water to the system and extinguish the fire. After the fire is extinguished, turn off the solenoid valve. Turn on the reset ball valve to pressurize the diaphragm chamber, and then close the reset ball valve after the diaphragm is reset. The water supply side pressure water is cut off by the deluge valve, and the system is restored to the servo state. Debugging of deluge alarm valve. Manual debugging. Before debugging the deluge valve, ensure that the solenoid valve is installed in the correct direction. The arrow on the solenoid valve points to the exit direction, and the components are assembled correctly and completely. Open the reset ball valve, alarm ball valve, manual startup valve, and drainage valve. Close all other valves. Inject pressure water not less than 0.14 megapascals into the water supply side. Slowly open the inlet fire signal butterfly valve. Pressure water enters the valve group. Hydraulic alarm bell alarm. Pressure switch action. Automatic drainage valve gets closed. When there is water discharge at the exit of the manual startup valve, turn off the manual startup valve, and after a certain period of time, 3 seconds to 100 seconds, the diaphragm gets reset. The pressure water is sealed by the diaphragm in the water supply side. The pressure switch and hydraulic alarm bell stop operating. The automatic drainage valve automatically opens to drain the residual water. When the automatic drainage valve no longer has water flow out, close the reset ball valve, the drainage valve, and open the outlet fire signal butterfly valve. At this moment, the manual debugging of the deluge valve group is complete, and the system is in the servo state. Electrical signal debugging. When the rain valve is in servo state, close the outlet fire signal butterfly valve. Open the drainage valve. The fire linkage controller sends start signal to the solenoid valve. The solenoid valve opens the drainage. The diaphragm chamber depressurized and the deluge valve opens. Then the hydraulic alarm bell alarms. The pressure switch acts. The solenoid valve closes after receiving closing signal from linkage controller. Open the reset ball valve to inject water into the diaphragm chamber to pressurize the diaphragm chamber, and the pressure water is sealed by the diaphragm to the water supply side. The pressure switch and hydraulic alarm bell stop operating, and the automatic drainage valve automatically opens to drain the residual water. When the automatic drainage valve no longer has excess water flowing out, close the reset ball valve and drainage valve. Open the outlet fire signal butterfly valve, and the deluge valve is electrically adjusted. Pneumatic debugging of dry control system. When commissioning as a dry control system, ensure that the components are properly assembled and complete. Close the outlet fire signal butterfly valve, dry guide tube ball valve, dry guide tube hand starting valve, and quick charging valve of the air maintenance device. Then start the air compressor and adjust the output pressure value of the air compressor. Adjust the pressure regulator on the air maintenance device to make sure the pressure value conform to the inflation pressure corresponding to the water supply pressure. Open the dry guide tube ball valve and the quick charging valve of the air maintenance device. Close the quick charge valve when the air pressure approaches the charge pressure, and make sure that the dry guide pipe does not leak. The deluge valve group is in server state after manual debugging and electrical signal debugging. Close the ball valve of the dry guide pipe and slowly open the manual starting valve of the dry guide pipe to exhaust. As the air pressure drops, the water switch acts to drain water, the deluge alarm valve acts, the anti-reset device continues to drain water, the hydraulic alarm bell alarms and the pressure switch act, and the deluge valve group works normally. Close the manual starting valve of the dry guide pipe. The water air switch is reset when the air pressure rises. Open the reset ball valve and inject water into the diaphragm chamber to pressurize the diaphragm. Then the diaphragm is reset. The pressure water is sealed by the diaphragm. The pressure switch and the hydraulic alarm bell stop operating, and the automatic drainage valve automatically opens to discharge the residual water. When the automatic drainage valve no longer has excess water, the reset ball valve is closed. Open the fire signal butterfly valve and dry guide pipe ball valve. The deluge valve group is restored to the condition, and the dry control system is debugged.